Hi to everybody. Today we are going to see freezing of meat and methods of freezing. In today's class, we are going to see what is happening in the freezing, different stages, how the water is getting converted into ice inside the food material. And second, we will be seeing the different methods of freezing the meat and meat products. So once again, I welcome you all to today's lecture. So what is freezing? Freezing is nothing but reducing the temperature of the meat or any food material below its freezing point. So here you can see the temperature of the meat is reduced below its freezing point. The freezing point of the meat is minus 1.5 degrees centigrade, or it ranges in the minus 1 to minus 3 degrees centigrade. The water in the food material, the water in the meat or in the food material during freezing, it is get converted into ice crystals. So that is what we do during the freezing. So how freezing help in preservation, or what is the goal of doing freezing? We basically have two goals in the freezing. One is to stop or lower the microbial growth. Another is to lower or stop the chemical reactions that is taking place in the food materials. How we stop the or lower the microbial growth in the food material or in the meat is that by reducing the water activity. So what is water activity? Water activity is the amount of water that is available for the microbes to utilize, that is for the movements, for the absorption of its nutrients. So that is a very simple way to define the water activity. So if the water activity is more, the microbes will multiply very fast. What we are doing here is, in the freezing, we are lowering the water activity. How? We are converting the water that is present inside the food materials into the crystal forms or into the ice crystals. So the available water for the microbes is reduced. So that is what we say, reducing the water activity. The second, you can see the mechanical formation of the ice crystals. So when you are doing the freezing, the water inside the food material, you know that the food material contains 70 to 75% is the water. That water which is present intracellular or intercellular is getting converted into the ice. So once it is get converted into the ice crystals, it restricts the microbial movement and it also reduces the absorption of the nutrients by the microbes. So that is how we are reducing or stopping the microbial growth. Another is by lowering the chemical reactions. As we already studied in the chilling method of preservation of meat, we have seen that every 10-degree decrease in the temperature of the reaction rate. The same principle is applied here also. When you freeze it, we are lowering the temperature. So the chemical reactions or the enzymatic reactions is slowed down or it is stopped. So this is a true principle. It is used in the freezing method of preservation of meat and meat products. So let's see why the meat is not freezing at 0 degrees centigrade. So this is a basic thing that we should understand. We know the freezing point of the pure water is 0 degrees centigrade. But in the case of meat, the water inside the meat or the muscle is not getting converted into ice at 0 degrees centigrade because of the presence of the solute. So let's see here, The meat mostly consists of water. We know that in the meat, 70 to 75% is of water, and it contains lots of soluble material like protein, fat, proteins, and other things. It will be contain like minerals and other things. It will be containing. Okay. When the soluble materials is present, it slows down the movement of the water molecules, and freezing occurs at the lower temperature. So the freezing, instead of freezing at 0 degree centigrade in the 0 degree, it will be much lower. It may be at minus 1.5, or it ranges from minus 1 to minus 3. Okay, so it is not freezing at 0 degrees. So in the case of meat, the freezing point of the meat ranges from minus 1 to minus 3, or if it is cast as a single blank, we can say it's minus 1.5. So we can see a 1 gram mole of soluble matter will decrease the freezing point by 1 degree centigrade. So let's understand certain terminologies that is related with freezing or chilling. What is the specific heat? Is the quantity of heat that is gained or lost by unit mass of food material to accomplish a unit change in the temperature without the change in the state. So here there is no change in the state. There is no change in the state means it's not from the solid to liquid or from liquid to the vapor form. There is no change. So specific heat means how much temperature has risen or lowered due to exchange of heat. That is called as a specific heat. It's the quantity of heat that is gained or lost by a unit mass of product or the food material to gain a unit to bring a change in temperature without change in the state. That is called a specific heat. What is sensible heat? Is that heat when added or subtracted from the material changes the temperature and it is sense. For example, if you take the water and if you just keep your hand, will feel some temperature. But when the same water, when it is get converted into the ice, we feel that ice is more cold than compared to the water. So we can sense the change in the temperature. So that is called as a sensible heat. Or you take a spoon and put it in the hot water. Initially, we will not feel the spoon is hot, the steel spoon. But after some time, when the water starts boiling, we find that we are not able to touch the spoon because the temperature of the spoon is also increased. So that is called a sensible heat. What is latent heat? So there is two things: latent heat of fusion and latent heat of melting. So is the heat required to change the physical state of the material at a constant temperature? For example, what is latent heat of melting? It is the amount of heat absorbed to change from, say for example, if you take the ice to get converted into water, how much heat it has to absorb. That is called latent heat of melting. For example, it needs around 334 joules of energy to melt 1 gram of ice into 1 gram of water at a constant temperature of 0 degrees centigrade. So that is called as a latent heat of melting. The latent heat of fusion means while the water is getting converted into ice, it will release certain heat. The water will release certain heat to get converted into ice. So that is called as a latent heat of fusion. What is supercooling? The cooling of liquid below its freezing point without it becoming solid. We have already seen that the pure water will freeze at 0 degrees centigrade, but that is not actually happening. We can see the sensible cooling is taking place, so there is a loss of sensible heat. Even after the 0 degrees centigrade, the cooling of the liquid below its freezing point without becoming solid. So here also we find that the liquid is in the liquid form only, or the water is in the liquid form only. After certain temperature, after certain point, say from there it will start losing the heat and crystallization take place, or the nucleation of the ice take place. So here it is a freezing point. So here the crystallization or the freezing point of the water is taking place. Okay. So supercooling means the cooling of the liquid below its freezing point. So this is the freezing point, actual freezing point. You can see this is the freezing point. But we find that the liquid, say for example the water, is below the freezing point also. It is in the liquid state only. This phenomena is called as a supercooling. Zone of maximum ice crystal formation. There is a temperature zone of maximum ice crystal formation. For most of the food, it ranges from -1 to -5 degrees centigrade. For the case of meat, it is -1.5. We already seen that. It is the zone or the range of temperature for most of the food materials where most of the water, that is intracellular or intercellular water, will get converted into ice. So this is called as a zone of maximum ice crystal formation. See, for example, for most of the, in the case of meat at -2 degrees centigrade, we find that 50% of the water is getting converted into ice. At between the range of -1, -3 or -5, we find that almost 75% of the water in the meat is getting converted into ice. So that is called as a zone of maximum ice crystal formation. So during the freezing, we have to see that the food material pass that zone as quick as possible. For example, if you take a meat, the meat core temperature should pass this temperature -1 to -5 as quick as possible, so the deterioration of the quality of the meat will be less. So in the case of, there are two types of freezing which we are going to discuss. In the case of slow freezing, you can find there it takes more time to pass through this zone of maximum ice crystal formation. So the deterioration in the quality of the meat or the food material will be more in slow freezing. Why? I'll be discussing that. But in the case of fast freezing, we can see it passed through the zone of maximum ice crystal formation at a very fast rate. So let's discuss how the ice crystal formation takes place. So for example, I'm taking here one muscle cell or a muscle cell I'm taking here. Okay. So we know that water, there is intracellular and intercellular water will be present. That is, inside the cell and between the cell, the water will be present. And we know that the solute concentration will be more inside the cell than compared to the outside. So when the solute concentration is more inside, naturally the rate of freezing will be less inside compared to outside, or rather the freezing takes place faster at outside compared to the inside. So when the freezing takes place, the ice crystals will be start forming. You can see this white spots, the ice crystal is forming. Especially in the case of slow freezing, it is mostly extracellular. So when the ice crystals start forming, the solute concentrations here it start increasing slightly. So the water will move out. So again the ice crystals will keep growing as the time keeps moving and moving. The ice crystals became larger and larger. You can see the ice crystal is becoming larger and larger. When the ice crystals became larger and larger as the time of freezing or the frozen storage goes on, what happens is it will start disrupting the cell membrane. But in the case of, this is what happens in the slow freezing. But in the case of quick freezing or the fast freezing, the ice crystals formed will be mostly intracellular and smaller in size, so it will not break the cell wall. So let's see ice crystal formation. The location of the ice crystal in tissues depend on the freezing rate. So there are two freezing systems we can say. One is called a slow freezing and another is called as a rapid freezing. Let's see what is happening in the slow freezing and rapid freezing in the coming slides. Next terminology that we have to understand is eutectic points. Eutectic points, the temperature where there is no further concentration of the solute due to freezing. does the solution start freezing. After certain temperature, there is no further concentration of the solute take place, or supersaturations of the solute will be taking place. And after that, we find the solution will start freezing. The solution as a whole will start freezing. So here we can see the comparison of the pure water and the mixture of water plus the solute, which we see in most of the food materials. So you can see here, this is the pure water. So the sensible heat is reduced. As the sensible heat reduces, then supercooling takes place. Then the ice formations will be there. So latent heat of fusion will be there, and it will be in the constant temperature for a long time, where most of the ices will be formed. Then the temperature reduces to the surrounding room temperature or the freezer room temperature. So this is for the pure water. In the case of food material, let's see the temperature reduces, the sensible heat is lost, and you get a supercooling effect is seen here. Then the ice crystallization begins at point B, and as the ice crystals forms, there's a latent heat of fusion. That is, when during the conversion of liquid to solid, the heat will be released. So the temperature will rise to the freezing point. Then again the solute concentrations will be there. Again the temperature reduces. Again the crystallization of the take place. That is at the U-take point. That is the E crystallization take place. Again the latent heat of crystallization will be there, or latent heat of fusion will be there. Because of that, the heat will be reduced. After certain points, ultimately it falls or comes down to the room temperature. So this I'm going to explain in the freezing cycle. So let's see the freezing cycle. We have different stages: A to B, A to S, then S to B, then B to C, C to D, D to E, and E to F. So A to S, already I told you the meat is cooled to below its freezing point, QF. This is the freezing point of the meat. At point S, the water remains in liquid. That is called supercooling. The water at S, it remains supercooling. Let's see what is happening during this stage, that is from S to B. The ice crystal begins to form. So here, from here, the nucleation of the ice crystals will begin, or the ice crystal will start begin, and the temperature rises rapidly to the freezing point. So when the ice crystals start beginning to form, what happens is, already I told you the latent heat of fusion. That is, when we convert the liquid to solid form, that is from the water to the ice, there's a release of heat. So as it releases, the temperature rises. Okay, so that is latent heat of crystallization is released. So here what is happening in the B to C? This is the zone where maximum ice crystals are formed. The heat is removed from the meat as latent heat of crystallization, but the temperature remains almost constant. The freezing point is depressed by increasing the solute concentration. So the solute will be there, as you know, as the water solidifies into ice, the solute concentration will be increased. So because of the solute concentration is increasing, the freezing is depressed by increasing the solute concentration in the unfrozen liquor, and the temperature falls slightly. So the temperature will start falling, and it is during this stage the major part of the ice crystal is formed. That is zone of maximum ice crystal formation, which we already discussed. So let's see what is happening in the C to D. D is the eutectic point. We can see here one of the solutes became supersaturated and crystallized out. So when it forms the crystallization, there is a latent heat of crystallization. That is, here is a heat is released, so the temperature will start increasing. So that's what we see here. One of the solute became supersaturated and the crystallized out. The latent heat of crystallization is released, and the temperature rises to the eutectic point for that solute. For a particular solute, it will be increasing. But in the case of meat, there is not only one solute, there's a complex of solutes will be there. Okay, that is why we use the terminology final eutectic points. Okay, so there will be complex of solutes. So it will be attaining eutectic point. Then DE, what is happening? The crystallization of the water and the solute. That's what I told, the solution will start forming the ice or in the crystal forms, the total time TF taken is determined by the rate at which the heat is removed. So the total time depends on how much heat is released. Then we come into the final state, that is EF. That is, finally it will attain the freezing room temperature. The temperature of the ice water mixture falls to the temperature of the freezer room. So surrounding temperature it will attain. Still, a portion of the water remains unfrozen at the temperature used in the commercial freezing. The amount depends on the type and composition of the food. So this is what happening in the freezing cycle. So I'll explain here once again. Sensibly heat will be lost, then it attains the supercooling point. Once it attains the supercooling point, that is at S, the ice crystals will start to begin, or nucleation of the ice will be taking place. As the nucleation takes place, latent heat of crystallization or latent heat of fusion, because of it the heat is released, so the temperature rises here. So again the latent heat of fusions will be continuing and the temperature remains almost constant in this range. As the water is getting converted into ice, the solid concentration increases, so further fall in the temperature will be there. So here it's the zone of maximized crystal formations. So once eutectic point is reached, the crystallization of the solution will be taking place. That is what happening in the DE. So after this complete point is reached, then the temperature falls rapidly to the surrounding temperature. So this is the freezing cycle or the freezing curve we can see. So with this basic, let's enter into the types of freezing. In the type of freezing, broadly we can say there are two types of freezing. One is called as a slow freezing and another is called as a quick freezing. So let's understand the freezing types. So there are different types of freezing. Already I told you there is a slow freezing and quick freezing. Quick freezing is, again we can say the rapid freezers are there and the ultra rapid freezers are there. Okay. The slow freezers means where you know that in the freezing takes place from the border of any food material, then it moves inside. So first the water at the side will freeze, then it keeps on moving inside and inside. Okay. So in the slow freezing, in 1 hour, 0.2 to 1 centimeter of this thickness will be frozen, or it will get freeze. Okay. Then it is called as a slow freezing. This is what happened in the home refrigerator. The slow freezing or still air freezers is a good example of slow freezers. Even in the chest freezer is a good example of slow freezers. Then quick freezers means the example is blast freezers and the plate freezers. Here the freezing take place at a rate of 1.5 or we can say 2 centimeter to 5 centimeter per hour. So first 1 hour the 5 centimeter thickness will be frozen. In the next 1 hour, that is in 2 hours, almost 10 centimeter of the side will be frozen. Then in 3 centimeter, almost 15 centimeter. So it goes like this. Okay. So that is in the quick freezers. We have two examples, the blast freezers and the plate freezers. Then rapid freezers, that is the freezing rate is 5 to 10 centimeter per hour. So first 1 hour, 5 centimeter will be frozen. In the second hour, almost 20 centimeter of the thickness will be frozen. So that is rapid freeze. That is fluidized bed freezing. Then ultra rapid freezers, where the freezing rate is 10 to 100 centimeter per hour. This is the fastest method of freezing. That is a cryogenic freeze. Okay. So ice crystal formation already we have seen. So in the slow freezing, the ice crystals formed are large and mostly extracellular because there is no movement of the freezing is at a slower rate. So first it will start like here and then it moves inside. In the quick freezing, it is mostly small and intracellular. So the disruptions of the cell wall is less. You can see the cell wall is, or the cell shape is maintained as same. Here you can see the cell shape is changed or the cell wall will be broken. So quick freezing, quick freezing and slow freezing. You can see here as the time goes, we can see the number of this dark blue color is the ice crystals which are small and mostly intracellular. The freezing is around 2 to 5 centimeter per hour. So at that fast rate it will be freezing So most of the ice crystals formed are small and mostly intracellular. So as the time goes, say 1 hour, some quantity of ice crystals will be formed. 2 hours, the number of ice crystals will be increasing. But the size is not going to increase in the case of quick freezing. But in the case of slow freezing, most of the ice crystals formed are large and intercellular. So they will be formed between the cells. Okay, between the cells it will be formed. So here you can see the ice crystals is formed at say for example this is the stage maybe of 3 hours we can consider. So after 6 hours what is happening? You can see the ice crystals has become larger and larger. So when it became larger and larger, what happens is there is no space for the ice crystals to form. So what it will start disturbing or disrupting the cell walls. So once it starts disrupting the cell walls, what happens is upon thawing, all the content inside the cell will come out upon thawing. So most of the nutrients will be lost. So the nutritive quality of the meat will be affected. So that is the main disadvantage of slow freezing. So you can see here slow as a quick freezing. What is happening? So this is the normal fresh meat. We can say you can see the cell here, that yellow color. In the static air freezing, that is there is no mechanical movement of the air, or it is a slow freezing. You can see this white ice crystal form is large and mostly extracellular. Here you can see the blast freezer, which is a quick freezing methods. Here you can see the ice crystal form is smaller and mostly intracellular. It is intracellular. Number of ice crystals will keep on increasing, but it will not affect the cell walls. Here you can see the very rapid chilling, that is like cryogenic freezing. You can see the small dots. The ice crystal formed is very small and is mostly intracellular. So it is not disturbing the cell wall, or cell wall is not broken. Here it is the cell wall is broken. As the time goes, this ice crystal keeps on increasing in size. So it will be affecting the cell walls. So upon thawing, most of the nutrients will be lost. The physical chemical properties of the cell will be lost. That is what happening in the slow freezing. That is why we always prefer quick freezing compared to slow freezing. So you can see here slow freezing, the ice crystals is formed. It became larger and larger. It will break the cell walls. Symbolically, it is represented here. Here you can see in the quick freezing or the fast freezing, the ice crystal formed is small and is mostly intracellular. It will not disturb the cell walls. So the integrity of the cell walls or the cell is maintained. Again, you can see here the freezing loss in the case of -20, -40, and it is -19. Liquid nitrogen is -196. So you can see the freezing loss. At -20, it is 0.5, 0.24, and 0.11. Okay, defrosting loss you can see 0.8, 0.7, and 0.8. So as we go lower and lower temperature or in the case of quick freezing, as we go lower and lower temperature, the freezing losses will be less, defrosting loss or thawing loss will be less, because there is no much destructions of the cell wall. Here, as we go lower and lower temperature, the faster rate, what happens? Most of the water will be frozen and the moisture will not be lost. So you can see the quick freezing, ice crystals formed is small and mostly intracellular. The cell walls are not broken upon thawing. Here you can see in the slow freezing, the ice crystal formed is large and it will break the cell walls. You can see the structure of the cell wall is disrupted and the cell wall has been ruptured here. So a lot of nutrients will be lost during the thawing process. So thawing loss will be more in the case of slow freezing compared to that of quick freezing. And understand what's the difference between the slow freezing and quick freezing. It is a slow process. I've already told it's 0.5 to 1 centimeter per hour it will be freezing. Fast freezing, it is more than 2 centimeter per hour, then it's a quick freezing. Or rather it's more than 2.5 to 5 centimeter, or it goes higher and higher when you go cryogenic freezing and such type of freezing. Maximum dislocation of the water we are seeing during the crystal formation. Here the maximum dislocation of the water, the minimal dislocation of the water, that is movement of water from the inside the cell to the outside. Large ice crystals are formed. Here small ice crystals are formed. Here the ice crystal forms are mostly extracellular. Here mostly intracellular. more damage to the fiber, less damage to the fiber, more drip loss on thawing. That the fluid that comes out of the meat is called as a drip. It will be more in the case of slow freezing. It will be less in the case of quick freezing. So more weight loss is there compared to less weight loss. So since drip is more, the nutritive loss is more. Here the nutritive loss is less. Chance for fat oxidation is more. Here the chance of fat oxidation is less. It has low keeping qualities. It has better keeping qualities. Microbes are longer exposed to adverse constituents. Here has shorter exposure. So the thermal shock of the microbes will be less in slow freezing compared to that of quick freezing. Because there's a rapid fall in the temperature, the thermal shock here it is more. So there's a more chance for the microbes to die. Deterioration of the quality is more here because the drip is more. There is a breakage of cell walls. Here the deterioration of the quality is less. So this is the difference between the slow freezing and quick freezing. That is why the quick freezing is more advantageous than slow freezing. So let's see what examples of slow freezing and quick freezing. The slow freezing, that is a chest freezer or the freezer that we use in our home. So this you must have seen in most of the shops or in the outlets. We can see this type of freezer that's called as a chest freezer. So it is inexpensive compared to it is less expensive. The temperature is minus 20 to minus 30. You can manage in this, but there is no mechanical movement. So naturally the cooling effect will be slower. The rate of cooling will be slow. So it comes under slow freezing. So let's see the different methods of quick freezing. So one is direct contact with the refrigerant. So that is example is a cryogenic freezing, which we are going to see. Indirect contact with the refrigerant. So that is the food material is not coming in direct contact with the refrigerant. So what is the refrigerant? Refrigerant is the one like a freon, ammonia, liquid nitrogen. All these are called as a refrigerant. Okay. In another class, I'll be explaining about the working of the freezers and the refrigerant. So it is indirect contact with the refrigerant. Example, the plate freezers. Freezing in air. That is, we are blowing the cold air. Example is a blast freezing. I repeat, direct contact with the refrigerant. That is, the food material come in direct contact with the refrigerant, like freon or liquid nitrogen or dry ice. That is called as a cryogenic freezing. Indirect contact with the refrigerant, that is a plate freezers, where the food material will not come in direct contact with the refrigerant. Freezing in air means the cold air is blown. The best example is the blast freezer. So let's see the cryogenic freezing. So what is the cryogenic freezing is a quick method of freezing. As already I told you, it's the fastest method of freezing. The freezing chamber, what are the things that will contain a freezing chamber? So we'll have a freezing chamber here, and it will have a lot of pipes and nozzles through which the refrigerant will be flowing, or it is moved. Then it contains the insulated pressurized tank containing the liquid nitrogen. That is here in the cryogenic freezing, we will be using the liquid nitrogen or the carbon dioxide, dry ice is used. So the liquid nitrogen temperature is minus 196 degrees centigrade. For the carbon dry ice, it is minus 78 degrees centigrade. So here the products will be conveyed or carried through a conveyor. It may be a spiral conveyor or a straight belt. Okay. The liquid refrigerant is sprayed on the product. So the liquid refrigerant will be sprayed on the products, and when it comes in contact with the product, which is having higher temperature, so when it comes in contact with the products, what happens is it boils and vaporizes. So the product will be evaporated, or it will be vaporized and lost into the atmosphere. That is what happening. So you know the liquid nitrogen is minus 196. So product temperature is naturally it will be higher than this. So there is an exchange of heat will be taking place. When it comes in this, because of the temperature of the temperature of the product, what happens is it will boils and it is vaporized. So heat transfer coefficient, you can see it's very high in the case of cryogenic freezing. The heat transfer per unit area per Kelvin, that is heat transfer coefficient, that is heat transfer per unit area per Kelvin. So it is 100 to 150. So you can see here, this is a patches, okay. We are spraying the liquid nitrogen. Liquid nitrogen is sprayed. The quantity approximately it shows that 1 to 1.5 kg of liquid nitrogen is required to freeze around 1 kg of product. Okay, that is approximately. The advantage is capital cost is less, but the running or the operation cost is high, because the whatever the liquid nitrogen we pay, it will be vaporized and it will go into the atmosphere. So that the running cost is very high. And then we have the dry ice. Dry ice also, dry ice generally used in the form of pellets. It will be because we cannot convert into liquid in the atmospheric pressure, so it will be in the form of pellets. So it can be mixed with the foods in the container to freeze. Normally we go with the liquid nitrogen is used in the cryogenic freezing. Normally used for small sized products like shrimps or hamburger patties. So this is mainly used for the shrimps, and small products will be using the cryogenic freezing, because and seasonal products, some seasonal products will be using this cryogenic freezing. Next is the plate freezers. Here, see, this is a plate freezers. There will be 7, this is a space. Okay, here, this is the hollow plates through which the refrigerant will be pumped. So the refrigerant will be flowing between this hollow space. This is hollow plates. So this is second hollow plates. This is the third hollow plates. Like that, there will be 7 or 8 hollow plates will be there. And we keep the food material in between this. So you can see this food material. This is the food materials. And will be a slight mechanical pressure. So this will be hydraulic ram will be there, which will be pushing the plates. So it will become it is applied. It will be applied here. You can see this is after keeping the food. Then the plate is pressed. Slight mechanical pressure is applied to improve the contact. So the exchange of heat will be faster. So here we will be using the refrigerant like Freon R404A refrigerants are commonly used. So we'll be using the refrigerant. Any refrigerant you can use it. Okay. Now present we will be using the Freon. It's commonly used. And when you press it out, it comes in close contact. And there will be exchange of heat. The temperature of this is in the plate freezer is -30 to -40 degrees centigrade is commonly followed. So there are 2 types of plate freezers. One is the horizontal plate freezers and the vertical plate freezers. So you can see this is hollow plates 1, 2, 3, 4, 5, 6, 7, 8. That's what I told you. Between this only we keep the food materials. So we keep the food on a tray. In the horizontal plate freezer, what we do, the food will be packed and it will be kept in the tray, and the tray will be put into this space. Okay, and by hydraulic pressure, the slight mechanical pressure, the food will come in close contact with this plates. That is, it will be slightly this hollow plates will be pushed. It will come in close contact, and after freezing, the trays will be taken and the food material will be frozen. Here the main advantage is that the freezing method is very fast, but only of uniform size material we cannot come and put the carcass in this size because the space is very less. So 70 to 80 space only will be there. The space between the plates will be less. So uniform size is required. And when you do the freezing, see that the packaging is not too thick. If it is too thick, the exchange of heat will be slowed down, the freezing efficiency will be reduced. Another thing, there should not be gap between the food material, air gap between the food materials and the package, because if the air gap is there, again the air will act as a insulator, so that will also reduce the efficiency. So it should be tightly packed, and then you have to keep for freezing. So in the case of vertical freezers, so in the case of vertical freezer, do not require trays. We do not require the trays, and the products are top fed. From the top, we will be feeding the food materials or whatever the product we want to freeze it out will be doing. The use of the plate freezer is usually limited to meat pieces which are relatively thin, and deboned and pre-packed meat and minced product like patties and such things we can use in the vertical plate freezers. Normally we go with the horizontal plate freezers. So this is the difference between the vertical and the horizontal plate freezers. So this is vertical plate freezers where we don't use the trays. Directly we will be feeding the food materials which has to be frozen. Okay, here we have to use the trays and it is kept inside the trays, and then the trays is put into this freezer between this space. So let's see how it is working like. So this is a refrigerant. The refrigerant will be pumped here. So between the plates, you can see this refrigerant is flowing. And this is the food materials. So, and this plate will be, slight mechanical pressure will be applied. So there is the exchange of heat will be taking place by conductions, and it will get frozen. So package thickness, the thickness of the package materials. Okay, normally we recommend 7 centimeter, not more than that. If it is more than that, the exchange of heat will be slow. Then there should not be air packets, large air pockets should not be there between the plates and the food materials. So that should also be removed. So advantages, good use of floor space. So less space, more can be frozen. Low operating cost. Little dehydration of the food. So there is no contact with the air. So dehydration will be very less. High rate of heat transfer is there. Food package keeps dimensions. So the dimensions will be, there is no shape, or the dehydration will not be there. So the food package keeps the dimension. Disadvantage is high capital cost. Capital cost is high. Size limitations. That's what I told. It should have uniform size product only. We cannot go with after certain limits. We cannot go with the products only for the products of regular geometry. That is, the shape should be of uniform. Size should be uniform. Shape should be uniform. You cannot freeze a carcass in this plate freezer because the space between this is less. So this is mainly used for freezing the cutlets, patties, nuggets, shrimps, and such products can be frozen in this plate freezers. It is a quick method of freezing. Now coming to the blast freezers. So again, here the temperature, it's a quick method of freezing. The cold air is blown. So here the cold air is blown. This is the crates, it is kept, the crates are kept and the cold air is blown. So here the temperature is minus 30 to minus 40 degrees centigrade. Even it goes up to minus 45 degrees centigrade. Okay. So normally we follow the temperature of minus 30 to minus 40 in the blast freezers. The air velocity, so 2 to 6 meter per second. Such high speed will be blowing the cold air. Okay, the cold air will be blown inside this chamber. So this is the chamber where the crates are kept and the cold air is blown. Okay. Here the product is placed in the freezer room and low temperature air is allowed to circulate around the product for the desired freezing time. So it will be frozen here. The product will be kept here and the cold air will be circulated and the product will get frozen. Once it frozen in the blast freezers, it is taken and kept in the frozen storage, which is normally maintained around less than minus 18 degrees centigrade. Because it is not advisable to store here itself because the cost of storage will be more. So once you freeze it out, remove from here, keep it in the frozen storage, which is maintained at less than minus 18 degrees centigrade. Because lower temperature if you go, the cost of storage will increase. So once you freeze it out, take it out, keep it in the frozen storage. So normally we say the freezing involves 2 stage or 3 stage, like one is frozen freezing, then frozen storage, then thawing. Okay. So here in the blast freezer, we freeze it out, then we keep it in the frozen storage. The freezing here takes place at minus 30 to minus 40. After freezing the product, we take it and keep it in the frozen storage. So the cost of storage can be reduced. The thickness of the package is also very important. If the thickness is too much, again, the freezing efficiency will be reduced. Time taken is 2 to 4 hours for small products, and for the larger products, it will take around 10 to 18 hours or more. So it depends upon the size of the products. Okay. What is the advantage? As I told in the plate freezers, we can go only with the uniform size and uniform shape. Here it is not like that. Any shape product or any size product, we can freeze it up. That is the main advantages of the blast freezer. Any size and any shape product, we can freeze it. Even you can freeze a carcass as a whole. Even you can freeze the cutlet. You can freeze the sausages. Any shape and any size you can freeze. That is the main advantages of blast freezers compared to that of the plate freezer. But the rate of freezing is faster in the plate freezer compared to that of the blast freezer, and the freezing cost is also better. Freezing rate is also less in the case of plate freezer compared to that of the blast freezer. So this is a this is a blast freeze, as you can see. This is a freezing room. So the cold air will be blown here. The crates are kept, and the cold air will be blown, and the products will get frozen here. So this is the blast freezers. This freezer only we are having in the meat technology unit. It's not a blast freezer because the air velocity is less there. In the case of blast freezers, the air velocity will be 3 to 6 meter per second. So at very high speed, we'll be blowing the air, and the temperature of the room will be around -30 to -40 degrees centigrade. Next, we have the spiral freezers. So this is a spiral freezers. This is a modified blast freezers, we can say. Now, in most of the industry, they are adapting this freezers. This is a modified air blast freezers in which continuous flexible mesh belt is formed into a spiral tire. So the belt will be just rotating. Okay, it will go from down to top. It will be just rotating. So during this time, the food material will get frozen. The main advantage is it requires very less space because it is like it's moving in the upward. So the floor space required is less. Requires relatively small floor space. High capacity, for example, 50 to 75 centimeter belt in a 32 tire spiral process can freeze up to 3,000 kgs per hour. So with this floor space, with this 32 tire spiral processor, we can freeze around 3,000 kgs per hour. So fast freezing we can do. Other advantages includes automatic loading and unloading, low maintenance cost, and flexibility for different products. So different products also we can freeze in this system. They are used for a wide range of products, including nuggets, cutlets, sausages, chicken portions. All these products can be frozen using the spiral freezers. So this is how we can see the products move here. This conveyor belt will be just moving. It will be moving, and when it comes out, it will be frozen, and the product will be coming out. The temperature again it is maintained is around -30 to -45 degrees centigrade. Even it goes up to -45 degrees centigrade. Here you can see the cold air will be blown with a very high speed. The cold air will be blown. So let's see the video here. You can see the belt is moving. This is a spiral freezers. So the belt will be just moving, and the food materials or the product is moving. You can see it moves here. The cold air is blown. So after freezing, it is coming out. So this is a spiral freezers. Now most of the companies is adapting this spiral freezers because the efficiency is more. So you can do turnover will also be increased. That is, you can see this belt is just rotating. The conveyor belt is rotating. So it has got frozen. By the time it comes out, it will be frozen, and it goes for packaging. Next is the tunnel freezer. So here the product usually travel horizontally. The products will be traveling horizontally through a long enclosed space. So this is enclosed space. The product will, this is a continuous process, like the product will just moving, and the temperature is maintained around -30 to -40 or 45 degree, -45 degrees centigrade. It will be maintained here. The cold air is blown just like a blast freezer, but the product usually travels horizontally through a long enclosed space. So this is the freezing tunnel. The product is moving through this conveyor. It will be getting inward. The cold air is circulated upward through the product. From the down, the cold air will be product. The product is conveyed through the tunnel by a series of stainless steel mesh belt. So this is a mesh belt on which the product is kept, and the belt will be just moving, or the conveyor will be moving, and it will be get frozen, and it will be coming out. So this is called as a tunnel freezer. So this is evaporation air chilling. Here in this chilling, normally this is followed for the chicken, where a large quantity or the large number of bird has to be frozen. This is mainly followed in the European countries. So here the cold, the water will be sprinkled on this, the carcasses, the poultry carcasses, and there will be a fan will be rotating. So evaporation brings cooling. That is a mechanism followed in the evaporation air chilling of poultry carcasses. So cold air will be blown. Already I explained this in the poultry processing. So this is called evaporation air chilling of poultry carcasses. So coming to the IQF or individual quick freezing. Let's see this what is happening. This is individual quick freezing. So this is a quick freezers IQF. Let's see what is happening in the IQF. Okay. So this is also called a fluidized bed freezers or the IQF individual quick freezing used for large scale productions. So when the production is more in that unit only we will be using this IQF. Here the small sized products like meat cubes or diced meat or French fries or small green peas like or carrot slices and such thing can be frozen here. Shrimps can be frozen. Small sized product only we can freeze here. The food particle is passed through the mesh. So the products will be passing through the mesh. So this is a mesh like, okay, this product will be, this is the input, the product will be moving through the mesh or a vibrating platforms. So regular products, we go with the mesh. For vibrating, sometimes instead of the mesh conveyor, we'll be using the vibrating platform. That is mainly used for the irregular shapes and sticky products. Okay, sticky products will be using this vibrating platforms will be used. Otherwise, we'll be going with the mesh conveyor. The cold air is blown at a high speed. Okay, the air is blown at a very high speed, say around 2 to 5 meters per second. It's such high speed. The cold air is blown. That is upward air stream. So from the bottom, we'll be just blowing the cold air. You can see here, the cold air is blown from the bottom to the upward. That is upward air stream is blown. The velocity of the air is adjusted. The velocity of the air is adjusted to lift the product off the belt. So the product will be just suspended in the air, we can see. Okay. The product will be tumbling in the air, you can say. The product will be float or tumbles in the air. That is so the exchange of heat will be very fast. That is the main advantage. Here, the combination of low temperature air, combination of low temperature of the air plus high heat transfer coefficient. We already discussed what is heat transfer coefficient. Because of the high speed of the air and cold air and the product size is small, the freezing will be very rapid. The freezing will be taking place at a very rapid rate. Okay. And the main advantage we can see here, the product remains separated from the neighboring product. The product will not, so if you freeze it out, the small products and then the blast freezer, the product will stick together. Here what happens is the product will not stick together. That is the main advantages of IQF. Individually, we are freezing each and every product. IQF, individual quick freezing. It is called as fluidized bed freezer because the product is just like a fluid. It will be floating in the air. That is why it's called as a fluidized bed freezers. Because we are blowing the air at a high speed, so the product will be floating in the air. So let's see a typical fluidized bed freezers. The air velocity is around 2 to 5 meters per second. We can adjust the air velocity. So according to just to move the to lift the product from the conveyor on the air. Okay. Then bed depth. The depth of the bed will be around 2 to 13 centimeter. Heat transfer coefficient is 30 to 60 watts per meter square per Kelvin. So this is a heat transfer coefficient. So let's see the practical storage life for the beef carcasses -18. This is storage. I told you storage temperature, or we can go, if you go lower and lower temperature, the storage life will keep on increasing. Lamb, it is 24 months, more than 24 months. Pork, it is 10 months, it is 15 months. Then edible offals, 1 to 2 months, it is 18 months. So if you go lower and lower temperature, the shelf life of the product can be increased, but the cost of storage will be also be increasing. So normally we store the food after freezing. We store the food material at less than -18 degrees centigrade. So let's see a comparative of the freezing cost per the unit cost for freezing. Okay, plate freezer, if it is X means the continuous blast freezer is 1.5 times the X. Suppose this is 100 means the continuous blast freezer, it comes around 150 rupees for freezing unit cost. Just an example I'm telling. So if it is using the refrigerant like freons, it is 3x. Where using liquid nitrogen means it is 6x. So thank you very much for listening to this class. Take care. In the next class, I will be talking about the effect of freezing on the food materials or in the meat. Thank you very much. Take care. God bless you all.